Good morning, trig students. I hope you're having a good, great, grand, and wonderful day. This is my last-ditch effort of trying to make sure everybody's on board with this idea of arc length and sector area. It seems like, I don't know if I didn't take it slow enough. I don't know if just everybody's being bombarded with lots of work. So if you already know this stuff, you're going to be able to blast through this assignment in literally a minute or two. If you're struggling with this, what I'm going to do and what the purpose of this video is to walk you through step by step exactly how to do these. And so I'm going to do these three problems. I know that it's entitled 2, but I'm going to do these three problems. And so let's walk through them. Okay, on this first one, it says if theta, which is equal to 210 degrees, is a central angle in a circle of radius 12 feet, find the A, length of the arc cut off by theta, and B, the area of the sector. Okay, so for these two things, we got to know arc length. Arc length is radius times theta. And remember, theta has got to be in radians. Okay, that's something we should know. And so the first thing I need to do is I need to look at this theta that's 210 and convert that and go, okay, so if theta is 210 degrees and I convert that and say, well, that's the same thing as pi over 180 degrees, that would give me 210 pi over 180, and this would reduce to 7 pi over 6. All right, easy enough. And so now I've got my pi. And I go, well, so therefore arc length, S, is equal to radius. We were told the radius is 12 feet times 7 pi over 6. I simplify that. 12 times 7 is 84. So I got 84 pi over 6 feet. And 84 is divisible by 16. And so I get that is 14 feet. I'm sorry, 14 pi feet. Let me get rid of that. 14 pi feet. And we actually had this problem before, and I just wanted to make sure that we are not missing it. I don't know if you remember it from last time, but we said, and that came out to be right at about 44.0 feet. Okay, if we were trying to find the sector area is equal to 1/2 theta times radius squared. Simple enough. Theta still has to be in radians. And so we say area is equal to 1/2 theta, 7 pi over 6, radius 12 feet. And we have to square that. And when I plug this all in, of course, the 12 squared is 144. And so you get 144 times 7. Grab my calculator, and that says it's about 1,008 pi all over 12 feet squared. And then you go, okay, so you divide 1,012 or 1,008 by 12, you get 84. So I got 84 pi feet squared, which is approximately 264 square feet. All right, next problem. We said if Nabia amazes us with her human protractor superpower, notices that a 777, a 777 jumbo jet made by Boeing, overhead subtends an angle of 0.65 degrees. If the jet has a length of 375 feet, find the altitude to the nearest 1,000 feet. And so what we're doing is we're saying there's this angle, and the plane is right here. There's my little plane. All right. Okay. And we're told that this angle right here is 0.65 degrees. It's an incredibly small angle. And we know that with an incredibly small angle and a huge radius, that the arc length right here really could be almost represented. I don't know why my highlighter isn't showing up. Could almost be represented as a straight line. That a straight line and an arc with such a huge radius and such a small angle are virtually the same thing. And so what we're doing is we're saying, well, arc length is equal to radius times theta, and we're going to use the 375 as the arc length. We've got theta, it's again in degrees, and so we got to convert it. So we say theta is equal to 0.65 degrees. We need to multiply that by pi over 180. I'm going to keep that number in my calculator because that's going to, if I just use this decimal approximation right away, my number is going to get further and further off. But my calculator says it's about 0.011344, so on. Okay? And so that's my theta. I don't know my radius, but I do know my arc length. So to get radius by itself, I have to go, well, radius is equal to arc length divided by theta. And so I know my arc length is 375. And I put that over this number. Okay? And so I say 375 divided by my previous answer, and I get 33055.257 dot 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 dot. And so if you were to round that to the nearest 1,000 feet, you'd go, man, that jet is flying at 33,000 feet. Great. Excuse me. Last problem. I love this kind of problem because it seems like it gives you just about everything you need, but you got to use what you've got to get a little bit more. It says a central angle of 3 pi over 2 radians cuts off an arc length of 36 pi. And so what this is telling us is this. Now 3 pi over 2, if you're unfamiliar with what that is, 3 pi over 2 is 1.5 pi. That's a huge angle. That goes all the way around to here. Okay? It looks like a Pac-Man. And we're saying that that arc length is 36 pi. So we know the angle is 3 pi over 2. We know the arc length is 36 pi. The question is, what is the area that all of this fills in? Okay, what's the area? What's the area of the sector formed? Well, what we're missing first is we're missing the radius. And so we have to find it. So to find the radius, we use our arc length formula. S is equal to radius times theta. And we say, all right, I know the arc length right here. I know theta right there. And so I can say 36 pi is equal to radius, which I don't know, times 3 pi over 2. To get rid of this fraction, I can just multiply both sides by the reciprocal and say 2 over 3 pi on both sides. 2 over 3 pi. And that gives me 72 pi over 3 pi is equal to, and the 2's cancel out and the 3 pi's cancel out, is equal to radius. Well, clearly the pi's cancel out, and 72 divided by 3 is 24. So we know the radius is 24. So now I just say, well, area is equal to 1/2 theta times radius squared. So 1/2 theta, in this case, we go back to the beginning. Theta was right there. 3 pi over 2 times radius right here squared. 24 units squared. And we plug all this in. We get 24 times 24 is 576. Times 3 is 1728. So we got 1728 pi all over 2 times 2 is 4. And so we divide that by 4 and we get that the area is equal to 432 pi, which is about 1357.168. So we go, well, that's about 1360. And there you have it. So at this point, you should be so familiar that you can do an arc length, you can do a sector area, and they're just real simple. You should be able to do these 3 problems without any problem. I hope to have your pizza challenges graded and back to you as soon as possible. I hope you all have a good, great, grand, wonderful day.